Hello everyone, welcome to vectors in the 3D. Here we have the x-axis, we have the y-axis, and we have the z-axis. We want to see on how you can obtain the modulus of vector in 3D. This is the origin. This is point B. Let's say here you have 2 units. From O to B, let's say you have 2 units. And from B to C, let's say you have 3 units. And from this point here to there, let's say you have 4 units. Now, to obtain OD, vector OD, you can either go direct or you move through this side, which will be given by OB plus vector BC plus vector CD. That's how you move to arrive at point OD. OB, BC plus CD. Now, in this diagram, OC is the hypotenuse, and OC squared is found by OB squared plus BC squared by Pythagoras theorem. Now, OD squared from that diagram, OD is here, OD will be obtained by the following. OD is equal to, OD is the hypotenuse, so it will be obtained by OC squared plus it will be OC squared plus CD squared. But as you can see there, OC squared, you can put this in bracket, OC squared is equal to OB squared plus BC squared, which means that OD squared is equal to OC, or I start with OB squared plus BC squared plus CD squared. In our given diagram, OB is, you can check this diagram here. Our OB is 2 units, our BC is 3 units, and our CD is 4 units. So substituting in that diagram, we find that OD squared is equal to 2 squared plus 3 squared plus 4 squared, which is equal to 2 squared is 4 plus 3 squared will give you 9 plus 4 squared will give you 16. So you have, which is equal to 29. So OD squared is equal to 29, which implies that OD is equal to square root of 29. So in general, the modulus of a vector whose component is x, y, z is given by the modulus. We write the modulus this way. V modulus will be given by x squared plus y squared plus z squared. Then you get the square root. For instance, if you are given this vector v, whose component is 1, 2, 3, and you are going to obtain the modulus of vector v, which is written this way, simply what you do, you square 1 plus the other component, which is 2, you square 2 plus the other component, you square it, and you obtain the square root. 1 squared is 1, the 2 squared is 4, 3 squared is 9. Then you get the square root. The square root that way, which is equal to square root of 14. So the modulus of a vector in 3D, you simply square their respective component. For instance, let's say also you have the vector v, whose component is 2, 4, 5. The modulus of this vector v, is given by 2 squared, which is the component along the x-axis, plus 4 squared, which is the component along the x-axis, plus 5 squared, which is the component along the z-axis, and then you get the square root. So 2 squared will give you 4, 4 squared will give you 16, plus 5 squared, which will give you 25. Then you get the square root. 4 plus 16 is 20, 20 plus 25 will give you 45. You obtain the square root of 45, whereby 45 can be written as 9 times 5. Then you get the square root of 9, which is 3, root of 5. So you can leave your answer in sand form that way. So generally note that modulus, we represent the modulus of a vector as that, and along the in 3D it is x squared plus y squared plus z squared square root. That is the modulus. Modulus means size of a vector. It is referred to as modulus, size, or the magnitude of a vector. In 3D, it is x squared plus y squared plus z squared. Then you obtain the square root, whereby x is the component along the x-axis, and y is the component along the y-axis, and the z is the component along the z-axis. Thanks so much for taking your time to study with me vectors. For more such videos, kindly tune on my YouTube channel so that we may continue learning together. Remember to subscribe to this channel so that you don't miss a single video which I upload for us every day.